All right, we're going to run through section 6-2, adding and subtracting rational expressions really quickly here. I just want you guys to see how I think and get through this stuff a little bit quicker as I upload all of this stuff to Google Classroom. So first things first, what do all rational expressions need before being combined? Well, we need to make sure we have common denominators. There's the answer to our EQ. Perfect. Okay, so we take a look. We need LCD. What is the common denominator that we could use here for 2 over 7 and 4 over 11? The answer would be 77. Multiply both top and bottom by 11 of this fraction. What are we going to have to multiply 11 by? 7. Okay. So whatever we do to the top, we have to do to the bottom. Now go ahead and multiply. We have 22 over 77 plus 28 over 77. We simplify by adding 22 plus 28. We get 50 over 77. Easy peasy, right? Won't even reduce. There's no common factors between those. So let's take a look at the next one. What happens when we throw a variable in there? Not much really changes. We just have to look for each part. So look at the numbers. Common factor, the least common multiple between 7 and 11 will be 77. But then we've got this x in here as well. So each fraction needs to have a 77 and an x. We need to find how can we get that missing part. How do we get the missing part here? We multiply again by 11, same as above. But with this one, we are missing not just the 7, but we are also missing the x. So you have to multiply by both. We multiply, we get 22 over 77x plus 28x over 77x. We want to reject the urge to cancel out the x's in this fraction here. Canceling them out is only just going to make you go backwards. We don't want to do that. So put it all over one fraction, and we take a look. 28x plus 22, they are not like terms. We're good to go. Okay? Nothing's going to reduce there. There are no common factors. So that's it. That's all you got to do. Let's take a look at rules to combine rational expressions. We want to simplify if possible, find the LCD, multiply each fraction by what we need to get that LCD. If we're subtracting, we need to make sure that every term in the numerator of that second fraction is being subtracted. Combine your numerators only, and then lastly, simplify if possible. I have up here, for finding the LCD, this won't always be the least common denominator, but the trick is you can always just multiply your denominators together to get a common denominator. In fact, that's what we're going to do most of the time anyway. Let's take a look. First step, I want to see if I can reduce. So 4x over 2y, they both have a common factor of 2. Now I have 2x over y and 5x. So I look at my LCD. I need to have this y here, but I also need to have a 5x. So just multiply and put them together. Your LCD is 5xy. So I take a look at this first one, 1y. The thing that I'm missing, the part of that I'm missing is 5x. So I multiply both 5x to top and bottom. And I take a look at the second fraction. I have the 5x, but I'm missing the y. So I need to multiply both top and bottom by y. That's going to give me everything over 5y. 5x times 2 gives me 10x. 6y times y gives me y squared. So I have this, 10x minus 6y squared over 5y. Now, not all of our terms in this fraction have a y or a factor of 5, so we cannot reduce anything. We're done. Okay? Move on to example number 2. 2x over 5x cubed. I can reduce an x from here, and that's going to change to a 2. 4y over 5, I can't reduce anything there. Now I take a look. Both of them have this 5, but I also need this x squared part that's in the denominator. Okay? I also need this part too. Now, that first fraction has my LCD, so I don't even need to touch it. Just the second one. And what part is it missing? The x squared. Put it all together. We have 2 plus 4x squared over 5x squared. You might be thinking, oh, I forgot a y here. Excuse me. So, hey, can we cancel out those x squareds? No, because not every term has an x squared. This 2 does not have that x squared, so we can't cancel out the x squared. We don't have y's, or we don't have multiples of 2 in each term. So that is as reduced as we are going to get. Let's go ahead and take a look at the next one. What do you notice about the denominators? They're identical. You're exactly right. So, since they're identical, my LCD is done for me. It's 5b minus 25. You might be thinking, hey, can't I factor out a 5 here? Sure. When I factor out a 5, I end up with 5 times b minus 5. But I look at each of these numerators, b minus 1 and b minus 6. I need them to match exactly that fraction b minus 5, or that factor of b minus 5. Since they don't, there's nothing that's going to cancel out. So I can just leave it as 5b minus 25 as my denominator, and then I can look and go ahead and combine my like terms. Well, I have a 1b and a 1b. When I combine those, that's 2b, not b squared, it's 2b. And then negative 1 and negative 6, combine them together, we have 7 negatives. 2b minus 7 over 5b minus 25. Once again, we have no common factors between any of our terms or the numerator and denominator, so I'm done. Moving on to the next one, we're moving like lightning. Here we go, 5k over 4k minus 5 minus 2k over k plus 2. I take a look at each of these denominators. 4k, negative 5, nothing in common. I'm not going to be able to factor anything out between this. K plus 2, nothing in common there. There's nothing in common between either of these denominators either. So they're both unique parts, so put them together. Multiply the denominators, just like we put as that asterisk by step 2. 4k minus 5 times k plus 2. There we go. That means this fraction is missing that k plus 2 part. Multiply it to both top and bottom. This one is missing the 4k minus 5 part. Now our denominators are identical, and we can go ahead and move forward. Okay? I'm going to write this as two fractions for right now. After I distribute the 5k to each, that gives me 5k squared plus 10k. I'm subtracting 8k squared minus 10k. Each of these is over the denominator, 4k minus 5 times k plus 2. The most frustrating thing about these problems is not how hard they are, it's just a lot of writing. It gets to be kind of a pain in the butt. But we'll work through it. We'll be fine. Now, this is step 4, where we say we have to subtract every part of the fraction. Okay? So here's what we do. 5k squared minus 8k squared. Those are my like terms. That gives me a negative 3k squared. Next, we take 10k minus a negative 10k, and this is where we have the problem. 10k minus a negative 10k. When we subtract two negative numbers, we actually add them together. Okay? So I'm going to just erase a couple of things here and rewrite this. Okay? This is how I work with these problems. Whenever I'm subtracting fractions, I change my signs. It's like I'm distributing the negative through. So when I distribute the negative through, this first sign is going to change to a positive. A positive 8k squared becomes negative, and the negative 10k becomes a positive. So I've rewritten my problem here, but it's still equivalent, and it's going to help make it a little bit easier for me to work with. So now 5k squared minus 8k squared, so it gives me a negative 3k squared. But now this is a little bit more clear. 10k plus 10k gives me 20k. All of that over the same denominator. Nothing changes there. 4k minus 5 times k plus 2. And there we are. And that's it. Okay. Lightning quick. We'll take a look at these. I look at my LCD. Needs to be the least common multiple between 3 and 2, which is 6. 3 times 2, they're both factors of 6, so that works. We've got a p. We also have this p plus 1. This fraction here, the first one, is missing a 2. 2 times 3 will give me that 6. That's what I want. Here, we're missing a 3 and a p plus 1. Okay? So when we multiply these all the way through, we get 2p plus 10 plus 9p times p plus 1. All this over 6p times p plus 1. I go ahead and simplify through 2p plus 10 plus multiplying through that 9p squared plus 9p. All of that over 6p times p plus 1. Combine your like terms. Put it in standard form. We have 9p squared. 2p plus 9p will give me 11p plus 10 all over 6p times p plus 1. There it is.